So there is a mutation testing. It is a fault based testing as part of white box testing. So test cases are designed to find specific types of faults in a program. That is why we create the test cases, right? So in mutation testing, a program is first tested using an initial test suite designed by using various white box testing strategies. That is what you studied in the previous lecture, right? So I mean, why you go for this mutation testing is that only to find certain types of errors, right? I mean, we try to see first what you try to do is you start with your initial testing. I mean, initial test suite, whatever you have designed, maybe based upon white box testing strategies. So first they will be tested on the program, right? After initial testing is complete, then we will be going for the mutation taking, right? So now, so as part of mutation testing, what you do? So you try to arbitrarily, you try to make changes to a program. So some changes you will make it to a program, right? So each time the program is changed, called a muted program, and the change affected is called mutant. That means, so whenever you change the code little bit, so that is what we call as a muted program. That means the program is changed, right? And whatever the change that you obtained, okay, that will be called as the mutant. You can think of the change affected is called a mutant. So that means you have a muted program, and whatever the program, whatever you muted, okay, so and the changed one is called as the mutant. Okay, so you have a muted program and you have a changed program. That is what you have. Okay, so that is what you call as mutant. That means you make some changes to the program and you will get a mutant. Okay, so underlying assumption is that all programming errors can be expressed as a combination of simple errors. That is true. Okay, so combination of certain number of simple errors. So usually you getting the all programming errors, right? Maybe you can think of any programming errors can be consisting of all the simple errors that you see in part of your program. So mutation operator makes specific changes to a program. So there is a mutation operator which actually make changes to the program. Okay, so that means, as I told you, there will be you going to make some arbitrary changes, right? A few arbitrary changes, right? So who is going to do this? So this will be done by a mutation operator. Nothing but, you can think of one mutation operator may delete a random statement. Okay, so you have designed a mutation operator in such a way that operator will delete a random statement. Okay, randomly it will delete a particular statement from a program. A mutant may or may not cause the error in the program. So now when you deleted a particular statement, what will happen? You get a mutant. Okay, you get a mutant, right? And now that particular mutant may, when you deleted the statement, may it introduce some error or may not it introduce some error, right? If no error is introduced, then the muted program and the original program are called equivalent programs, right? So that means after, so before you remove a statement from a program, you do not have any error, and after you remove one statement from the program, randomly you removed or deleted a statement from the program, and then also it is not going to introduce any error. That means what? So actually these two programs, they may be equivalent programs in terms of testing. They are equivalent because they are not going to introduce any new error, right? Even if you delete that particular statement, so it is not going to show you any error. That means in terms of testing, so they are two equivalent programs. Okay, so now, so muted program is tested against a test suite of the program. Now what you will do is, whatever the test cases we have designed, okay, so with those test cases, again you will try with this muted program. Okay, that means you will be trying with the mutant, right? If there exists at least one test case for which the muted program yields an incorrect result, then the mutant is dead. Okay, so that means with those test cases, when you execute on that muted program, if at all it is going to give any incorrect results, that means it is failing a test case. That means there are some bugs. There are some bugs. Whenever there is a bug, that means the mutant is dead. Okay. Whenever there is a error, okay, so then we can say it is a mutant. Okay, mutant is dead. Otherwise, it is alive. Okay, so test cases are enhanced to kill those mutants. That means you try to, so its objective is that, so you always need to kill the mutant. That means you try to dictate the errors. When you are killing the mutant means what? That means it is introducing a error. That means it is giving incorrect result. That means you are trying to identify a error. Okay, so our objective mutation testing is to identify certain type of errors, right? So that is the reason why what you do. So you try to remove certain statement, check them against the test cases whatever that you have initially have. Okay, and then you apply the test cases, then you see whether it is giving any incorrect result or not. So if it is giving incorrect result, that means the mutant is dead. Okay, and here our objective is to kill as many as number of mutants, right? Or you kill that particular mutant. Okay, so that means you have to somehow introduce. So this is the way that you actually enhancing the test cases. Okay, so our objective is that you killing a mutant. That means you actually going to see a new error. Okay, you trying to see any incorrect error or something like that, right? So remember that there is a possibility of a muted program to be equivalent program. When this is the case, it is futile to try to design test cases that would identify error. Okay, so that means, so let's say you mutated the program, right? So and then in that case you find that the original program and mutated program, they both are equivalent in terms of test. There is no point of there is no point of going through. Okay, if it is not if it is not a equivalent, then only it is a good thing that you should always design the test cases so as to identify the error. Okay. So advantages of this is that it can be automated to a great extent by certain primitive changes. We can generate mutants, right? So every time you remove or delete a particular statement, right? So or you make some changes to the program so as to create several mutants. Okay, so maybe one example is deleting definitions, right? Or maybe deleting a statement. So they are all primitive changes. Then what is the disadvantages, right? So the disadvantages here is computationally very expensive since large number of mutations. So I mean you have thousands of lines of code. That means if you remove randomly thousands of lines, okay, every time one line, okay, you remove or make changes. So that means you require a lot of time and also some computation, right? Once you created a muted program or the mutant, then again you apply all the test cases that you have designed before, right? So against that particular mutant, right? So it is not suitable for manual testing. If someone is going through manually carrying out the testing, so probably it is very much difficult, right? So why, as I said you, so you removed one statement and then again you all apply all the test cases, and then you replace that particular statement, and you the second time you will be going through another another statement you will be removing, and then again you will be applying all the test cases, right? So which is a very tedious task for manual testers, right? So there are test tools which automatically generate the mutants. Okay, so you must have to use some test tools which can automatically generate these all mutants, right? So the integration testing, so now this is all about the unit testing, right? We have seen, right? Now we have the integration testing, right? So it is carried out after all, at least some of the modules have been unit tested. That means once the unit testing is carried out, then only you will be taking up them for the integration testing, right? Objective of testing is to check whether the different modules of a program interface with each other properly or not. So this is where you try to see that whether the program interface is working properly or not, right? Any one of the mixture of the following approaches can be used to develop the test plan. So this is what we do. So there is a big bang approach, there is a top-down approach, there is a bottom-up approach, and there is a mixed. Maybe you sometimes use big bang, top-down, or top-down, bottom-up. So like this, so you can always come up with some mixed approach, right? So what is a big bang? So as part of big bang approach, how you try to do, all modules making up a system are integrated in a single step. That means, once you integrate all of them at once, okay, in a single step. You do not go through any integration plan. Okay, so difficult to localize errors, as the error may potentially lie in any of the models. So this sort of integration testing can be carried out, but it will be very difficult if there is any error, because identifying or locating a error is difficult if you at once if you integrate all of the modules and then try to test. Okay, so then it is during debugging it is a problem. Okay, if you're going through top-down approach, what will happen? It starts with the root module in the structure chart and one or two. So that means first you will be, you develop, you first come up with the top, maybe root module, and then you will be going through its root, its leaf, maybe it's children, one or two, right? Or the subordinate modules of the root module. And so here usually when you're going through top-down approach, you usually require what? You require stubs. Okay, you require stubs. But if you are going through bottom-up approach, you require drivers. Okay, so that is what the question I also given you in the exam today, right? So we have already talked about this. When I was talking about the stubs and drivers, maybe 2 days. I mean, previous 2 lectures, I have already talked about this. So that is what, right? Again, we are seeing this. You understand, right? Now there is a bottom-up approach, right? First, the modules for each subsystem are integrated. So that means first you will be integrating the subsystems, and then you will be applying the testing, right? Integration testing a subsystem is to state whether the interfaces among interfaces also various modules making up the subsystem work satisfactorily or not, right? So when you are going through the bottom-up approach, you really require test drivers, right? So the dummy functions are really required. You need to have them, right? Because you first you integrating the leaf level nodes, and then you and then you will be going and integrating them so as to make the complete testing for all the modules, right? So and also sometimes when you call as mixed, so it is a sandwiched approach, or you can think of, you can make the combination of top down and bottom up approach, right? So this is a way that people apply. Sometimes you try to take some benefits of top down approach, and you try to take some benefits of the bottom up approach, and then you come up with a own style of approach, that is what we call as mixed approach. Now the finally you have the system testing, right? So as part of system testing, what do we try to do? All units of a program have been integrated together, okay, and tested. System testing is undertaken, right? Once you have done the unit testing, right, as well as you have carried out the integrated testing, then only we will go for the system testing. That is what you say. System tests are designed to validate a fully developed system to assure it meets the user requirements, right? So whatever the requirements that are there as part of the SRS document, so against that SRS document requirements, we have the test cases are designed based on that SRS document, right? And we try to ensure that here we meet all of the SRS requirement. I mean the requirements that are collected or represented in the SRS document, right? So here there are 3 types of testing carried out as part of system testing. One is called as alpha testing. So where the system testing is carried out by the test team with the developing organization, right? So that means alpha testing is something the testers or the test team, whoever there, so they will carry out this testing, okay, within that particular developing organization. I mean where they are developing that software. So the test team is going to test this. That is what we call as alpha testing. And you heard about sometimes there is the product is in alpha testing or the product is in beta testing. So you might have heard about this, the words probably. Sometimes sometimes these beta testing are released and kept open. So asking different users to use that particular software and give some feedback, right? So that is what exactly a beta testing. Now beta testing is performed, this testing is performed by a select group of friendly customers, right? So that means so this product will be given to certainly friendly customers, asking them to use that and then try to take, they try to get the feedback from the system, whether that is what exactly what customer exactly really wants, whether their requirements are met or not, whether things are working according to them or not. So that is what you try to do as part of beta testing, right? That means some group of friendly customers, okay? So they're going to test this, and then you have finally a acceptance testing. So it is performed by the customer to determine whether to accept the delivery of the system or not. So now before they're going to accept the delivery of the system, that means the development team says that we have completely developed your system, okay, whatever you want. Now this particular test will be carried out just before the customer is going to accept the test, accept the delivery of the system, right? So they will see, they will test, and whether the requirements are met or not. If that the requirements are met, then only they're going to accept. If the requirements are not met, probably they are not going to accept, right? So this is what we call as a acceptance testing, right? This is part of your system testing. So your system test cases are classified into functionality and performance test cases, right? So, so usually whenever you carry out any system test cases, usually you will carry out the functionality as well as performance test cases. That means you functional and non-functional test cases, that we can say indirectly, because that is what exactly going to test the requirements of the user, right? So before a fully integrated system is accepted for system testing, smoke testing is performed. There is something called smoke testing is performed. Before this integrated system is accepted for the system testing. That means before you carry out the system testing, you should carry out something called as smoke testing. So what is that smoke testing? So initiated before system testing, ensure that the system testing would be meaningful or whether many parts of the software would fail. So that means, so you will be designing few test cases, okay, and then you try to see that whether the basic functionalities of the system are working or not, okay. So if that basic system functionalities are not working, probably you will not be going for the system testing, okay. Otherwise what will happen? So it is a waste of time, right? It is a waste of time. That means that will not be meaningful and many parts of the software would fail, right? So if you before you carry out the system testing, you usually carry out something called as smoke testing, okay. That is, you take certain few test cases and then they will be tried, right? So now as part of your performance testing, what you try to do, we address on a non-functional requirements, right? So where you see, whether the maybe sometimes they involve testing hardware as well as software together, right? Whether because these are all part of non-functional, right? Maybe timing constraints, right? Maybe any other constraints that the hardware has or the software has, or their integrations, right? So there are several categories of performance testing. Again, we have, right? So one such performance testing is called as a stress testing. So where this is what we call it endurance testing, right? Sometimes, so it all imposes abnormal input to the stress the capabilities of the software. That means you give excess, you can say abnormal input will be given to the system, by giving abnormal input to the system to try whether this particular software is going to handle the stress or not. Okay, so that means you will be giving input data volume, input data rate, processing time, utilization of memory are tested beyond this design capacity. That means when you give a large amount of, you will be giving some abnormal input to the system in such a way that you will be going to see that whether whether the input data volume or the data rate at which you will be giving the data to the system or processing. So, or how better way this software is actually utilizing the memory. So these all will be tested, right? So that is what the stress. I know you will be like, maybe you can think of so something like this. The more the stress given to a student, probably you will be working better. Okay, maybe you will be. I mean, so this is what the assumption. Like that means you will be given much of stress, right? Hmm. So here is an example. Okay, I quote like this. Okay, so something like that. So the stress testing is carried out to see whether um, whether the capabilities of the software is up to mark or not. And there is just this stress testing if the requirements is to handle the specified number of users or the devices in terms of number of users or the devices. So you can always think of stress testing evaluates the system performance when all users or devices are busy simultaneously, right? So now you can think of like this. So how many number of users a particular system is handling at a time. Okay, making parallelly busy certain number of users, right? So then how the system going on, right? So this is what we call as stress testing, right? If an operating system is supposed to support 15 multi-programmed objects, then you try to attempt to run 15 or more number of jobs simultaneously, right? So you can think of like this in case of operating system, right? So your operating system is going to handle, let's say, 15 multiple jobs at a time, right? Then while stress testing, what you will be doing is you will be giving more than 15 and more than 15 number of jobs you will be submitting to the system. As a result, you will try to see that whether still your software is or the software is I mean operating system is able to handle or not. Okay, so a real-time system might be tested to determine the effect of simultaneously arrival of several high priority interrupts. So you can think of in case of real-time operating system. So you can see that there will be several high priority interrupts coming together at the same time. So in that case, how the system is going to able to handle those requests or the interrupts. So you can, this can be another example of stress testing. So the stress testing involves an element of time or size. That means here, I mean, what volume of input data that you are giving and how much, per unit time, how many number of such records are transferred or the transactions are carried out, or how many number of maximum number of users are active at that particular time, and what is the volume of data that is given to the system. So those sort of things will be tested against during this stress testing, right? There are stress testing may not be applicable to many types of systems. Okay, so it is up to you whether it is for some applications, whether if it is really required, so you will be going through, otherwise it is not required, right? So now there is a volume testing. So here it addresses handling large amount of data in the system. Okay, so I mean you will be able to see that whether how these whether these data structures like queues, stacks, arrays, whatever you have designed, right? So whether they are large enough to handle all the possible situations or not, whether you have created some fields or records or files. Okay, they are stressed to check if the data size can accommodate all the possible data volumes, right? Maybe as part of a compiler, we see there is a symbol table created, right? Now, so symbol table is nothing but it's a data structure, right? So you can think of like whether the compiler is able to handle with whatever the data structure that it comes with, right? So or not. So these can be tested. Okay, that is what volume testing. That means it's all about related to data structure, files, records, because it is going to store your data, right? Volume of data. So then you have a configuration testing, which analyze the system behavior in various hardware and software configurations specified in the requirements. So sometimes the systems are built in various configuration for different users, like you understand, right? So the same system can be configured according to different types of users who are going to use the system, right? Now, for instance, a minimal system may serve a single user, right? Or maybe you have some other additional configuration where it will allow additional number of users, right? So you can think of, right? So you create, so for single user, maybe you have certain sort of configurations, right? And for more number of users, if you are going to allow to the system, so more different types of users, then maybe your configuration is little bit different, right? Because all of these users going to use the same sort of memory space, or maybe going to use the same hard disk, I mean memory. So, or they may try to use the same processor, right? So they try to give multiple requests at the same time. That means you should also see this configuration, doing carrying out this configuration testing to see this sort of behavior, right? Whether they act according to the or not. So there is a compatibility testing. So these tests are needed when the system interfaces with other systems, right? Check whether the interface functions are as required, right? So that means when you are trying to interface this particular system or the software that you have developed with other systems, and during that particular point of time, whether things are working at the interface, the interface functions are whether they are working fine or not, whether they are as required or not. So develop whatever the interface functions that you have developed, so that is as required or not. If it is not required, then maybe you need to make, you will have to see the compatibility testing, right? So part of this, you need to ensure that, okay? Ensure that the interface functions are developed as required, okay? So now one compatibility testing, you can see here is an example, right? So if a system is to communicate with a large database system to retrieve information, compatibility test examines speed and accuracy of retrieval, right? So that means, so your system or the software which is going to interact with a database system to retrieve some information, in that case, so you will be seeing that compatibility test through which you will be try to see, I mean, what is the speed and accuracy of retrieval, right? Through this particular interface, whatever the interface through which you will be checking that, within how much time or at what speed you will be able to retrieve your data from the database server, because that is another system, right? And there is a recovery testing. So these tests check response to presence of faults or to the loss of data, power devices, or services, right? So it can happen like, I mean, let's say when the system fails, right? Whether they will be able to recover the system or not, whether suddenly, let's say power, if there is a loss of power, as a result, maybe the system may fail, right? As a result, whether you will be able to recover the data whatever you created in the past, or the services, whether those services will be again available to to the users or not, after a certain presence of some faults or to the loss, you can understand, right? So subject to loss of system resources if the system recovers properly, right? So maybe you should check whether is there any loss of the system resources. That means whether so you see sometimes it happens also, right? So if you do not have a UPS system to your computer, sometimes it, because of abrupt power supply, loss of power supply, as a result, sometimes maybe some of the circuitry of your computer gets off. As a result, sometimes you get some problem in your motherboard, right? Or in any other components. That's the reason why you always follow sometimes UPS, because to save your system from the power fluctuations, right? So this is way, right? So you try to always test according to with respect to this aspect, right? So that is what we are trying to say. And there is a maintenance testing. So here you going through, you following some diagnostic tools or procedures to help find source of problems, right? What are the causes of those problems, if at all it has any problems, right? So maybe it may be required to supply memory maps, diagnostic programs, traces of transactions, circuit diagrams, so anything, you can follow these all things to, particularly find the problem where this particular error is, right? This is what exactly we try to do the testing during maintenance. That is what we call as maintenance testing. So as part of maintenance testing, we try to verify all required artifacts for the maintenance exist. Okay, I mean whatever, when you go for a maintenance, so usually all of the required artifacts should be there. Then function whether they function properly or not. Right. So you going to check, okay, through maintenance. And there is a documentation tests. Okay, so check that required documents exist or not, whether the user guides are available, I mean created, whether that is conforming to the I mean you should test that, you should check that whether user guides are is according provided according to the system that you have developed, like. And if at all any maintenance guides you wanted to give, so you can keep them also, and those things will be checked, whether technical documents also, whether they are developed according to the required is required, right? So everything will be checked during the documentation testing, right? So sometimes requirements to specify, so format and audience of specific documents, right? You need to always mention that who is going through these particular documents, whether like as I told you, right? You have created a what SRS document, then you will be saying that this particular document will be for the simple users, right, or the customers. So then you do have some sort of format, right? And the same SRS can be presented to maybe the designers, maybe you follow some other format, right? So those things you will be checking, right, whether the formats are as per the audience who is going through that particular documents are evaluated for compliance, that is what, whether they comply or not according to. So this is all about the testing, right? So now so you can think of there is a, so even if you find some of these errors, so feel still there will be certain number of errors, right? So make a few arbitrary changes to the program. Artificial errors are seeded into the program. Check how many of the seeded errors are detected during testing. That means sometimes to see that how many really errors being removed by that particular program, maybe to see that, what you try to do is you certainly add some of the changes to the program, and then that means they are the artificial errors, right? So you try to make some changes, and as a result you try to create, I mean you try to seed some errors artificially, right? That is what, and then you try to apply your testing, and then you try to detect those errors, right? That is what we try to see, usually. So that is what we call as error seeding. So maybe you can think of n be the total number of errors in the system, and small n of these errors be found by testing, and s be the total number of seeded errors, right? So I mean smallest of is the seeded errors to be found during testing, right? So now you can understand these are all different formalisms, right? One says the total number of errors that will be there part of the system. So small n be the errors found by testing. You by applying testing, so you find n, okay, n number of errors, right? And capital S may be the total number of seeded errors. Sometimes you have seeded some errors, as I told you, right, in the previous slide, right? So you will be adding some artificial errors, right, by removing some statements, okay, or you introducing by which you try to introduce some errors, right? So you have capital S number of errors can be seeded, and then small s with the seeded errors be found during testing. That means when you apply testing, so you be able to detect small s. That means you are not able to detect all the seeded errors, maybe you detected some errors, okay? So now similarly n is the subset of capital N, right? You can think of the number of errors that you have there, so you found only small n. So similarly like this, okay? Then you can always say no, you follow this condition, small n by capital N is equal to small n s by capital S. Because so if there are capital N number of errors, then you will be, if you will be able to detect small number of n, that means if you seed capital S number of errors, then also you will be able to get small s number of errors getting detected, right? So it is always equivalent to each other, right? So now from which you can get by rewriting this equation, so you can always get the capital N. So capital N is equal to S into N by S. Now then you can find always the remaining number of defects. The remaining number of defect is something. So you have capital N and you have removed all the small n, I mean the errors that you have detected. Okay, that means left are the remaining defects, right? So now if you apply this, I mean you apply to the second equation, you can apply minus n on both sides, then n minus n is the remaining defects. So then the right side is something n into s minus s by small s. So you rearrange that equation to get this. Okay, so this is the way that you will always be getting some remaining defects. So error seeding is the kind of seeded errors should match closely with the existing errors, right? So however, it is difficult to predict the types of errors that exist. So this is also a very difficult difficulty, right? You cannot always easily predict what type of errors that exist, right? So categories of remaining errors can be estimated by analyzing historical data from similar project. Maybe we will be going through similar kind of projects through which you will be able to, by going through the available historical data, you always can, estimate. So now, so I stop at this point of time. So we are not going to talk about the regression testing, as well as I'm not going to talk about the gray box testing. So there is a gray box testing which is actually meant for the object oriented testing, right? I mean, if you have applied the object oriented paradigms, right, then you have the object, so usually ultimately you have certain number of objects in your program, right? So then the whatever the testing I have told you, so they cannot be directly applied to them for a object oriented software design programs, right? So now there you need a gray box testing. You should learn about this. Maybe it will be useful, right? So because you will be testing the by using some state models, because you have seen that there are UML state diagrams, right? You have seen the use case diagrams, right? You have seen the class diagrams, you have seen the sequence diagrams. Now there are test cases can be designed, developed based upon those models, right? So based upon those state models, based upon those use case models, based upon those sequence diagrams, class diagrams, you can always design some test cases. But so because of the time constraints, so because you will have to it is very difficult for us to complete many other important topics as of now. So maybe you can read yourself, right? That is what we call as gray box testing. We are not talking now, right? So and also I am not talking about this regression testing. So it is only one topic I left to you, so you go and read yourself something that is regression testing, right? As well as you go through the gray box testing. So right, so now I stop at this point of time. Maybe so few students called me and they get their doubts cleared, right, whenever they find. But you can also call me any time, any doubt, right? And these videos are available to you, right? And so something you can so right, so all the best, right? So for your end exams, maybe I'm not going to take this subject again, right? So this is my last lecture, right? So any doubts so far, student? Students?
No, sir. No, sir.
Okay. So Sunday you have 11 o'clock the exam, right? So it is optional. So you can give your test, right? So I will not call and write mail again, right? So you come and give this exam at 11 o'clock, right? So right, I stop the recording.
Sir, same number of question will be there.